Everybody, it's from Jayashree. I'm going to take the universal shift registers under the unit of registers and counters. Okay, let us see what do you mean by universal and what do you mean by shift registers. Let us see everything in detail. Okay, so this is what universal shift registers. This is what the universal shift registers block diagram. Okay, from the left end we see that serial input for right shift. Okay, we can perform four operations in this universal shift register: serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out. We can perform four operations under this universal shift registers. Okay, so for in the from the left side we can see the serial input for right shift. Okay, so in the red it indicates the red column, right? So which indicates SI SO. Okay, in the right side indicates serial input for left shift. Okay, so we need to shift the bit, each and every bit left side. We can use this right side serial input for left bit. If you want to shift the each and every bit right side, we want to shift serial input for right shift. Okay, next one, parallel input bits. Okay, this is what parallel input bits. We are giving the top of this universal shift register from B0 to B3 or whatever it may be the numbers. Okay, so we are giving the parallel inputs for each block 4:1 max. Okay, at the straight bottom at the top we can give the parallel input bits, right? And similarly here parallel output bits, at the bottom side we can get the parallel output bits. This is what this will perform, this parallel in, parallel out, parallel in, serial out. Okay, and also these four operations are under this single block diagram. That is what this universal shift registers, which is very important while designing the circuit with serial operation and parallel operation or serial input, right? So this is what the universal shift registers block diagram explanation. The logic inside the shift register control the behavior based on the shift control inputs, right? So the logic, for example 1 or 0 or whatever may be the logic, it will control the behavior of the shift control inputs. Here the general overall the functionality of this. Okay, here is a general overview of this functionality. When all the control shift are 0, the shift register remain in parallel load mode. Okay, and the data from the D inputs is loaded into the flip flops. Okay, when the shift control input specify a left or right shift, and data stored in the flip flop is shifted accordingly. Okay, the clock input CL synchronize the shifting operation, ensuring that data is shifted only when clock signal transitions. Okay, so first one, when all the shift inputs are 0, the shift remain in parallel load operation. When the shift input says way left or right side, the data in the flip flop is shifted accordingly. Okay, this is what this universal shift register operation. It is also the digital circuit capable of shifting data in both operation left and right, as well as performing parallel loading. It typically consisting of a combination of flip-flops, multiplexer and logic gates. Okay, this four combination, this four serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out. These four combinations form the universal shift register in a digital circuit capable of shifting data in both directions, left or right, as well as performing parallel loading. Okay, so these are the block diagram explanation of this universal shift registers. So here it is what D0, D1, D2, D3, right? So D0, D1, D2, I'm sorry, 1 second, wait. This D0, D1, D2, D3, these presents the individual data inputs of the shift register. Each input corresponds to the one bit of the data. Okay, this is the data input line where parallel data can be loaded to the shift register. S0, S1, S2, S3, these are the shift control inputs. These determine the direction and mode of shifting. This is the clock input that synchronizes the shifting operation. The OS indicates these are the outputs of the flip-flops within the shift register. Each flip-flop output corresponds to one bit of shifted data. Okay, so let us summarize the universal shift register block diagram. This is what the universal shift register block diagram. It will perform the four operations. 1 second, wait. So it will perform four operations: universal shift registers, serial in, serial out, serial in, parallel out, parallel in, parallel out, parallel in, serial out. From the, if you want to shift the bits towards the right side, we are giving the serial input for right shift. Okay, we are giving the bit to the right side and the charter shifting towards the right side. If you want to if you want to move the bit towards the left side, we will give the bit towards the left side, and we are giving the input as the right bit and started moving. So this is what the universal shift register. And parallel input data. This parallel input data blocks this. The four input data is giving at the top side of this block register, 4:1 multiplexer, and bottom inputs we can receive the parallel outputs data. So thank you all. We will see the next class.